the idea is to give you an overview where we're coming from. So going a bit back in time, what the original idea was and how this evolved. And then I'll try to show you what the current setup is and how this all works at the moment. And then I'll try to just load up the web interface and show you a few things that you may have missed just because they're a bit hidden. And then please at any point just interrupt me because it's really getting late after a full day of conferences and talks. So get to do that a bit interactively. So currently, Astro-COLIBRI is also a group of people. So this picture was taken exactly a year ago at the last workshop, and most of them are still around and here in the room. Funding-wise, we are currently supported by a grant from the French national agency. This is ANR and two European projects. One ending end of this year, and the other one, the ACME one, just starting. So there's the kickoff meeting today, and this is also coming through to Astro-COLIBRI. Where it all started, I mean, we heard it a couple of times today. In 2017, there was this nice detection of another high-energy neutrino by IceCube. And then the correlated detection of a flaring blazar in GeV, and then a ground-based detection by MAGIC as well in the high GeV range. This was one of these multi-messenger breakthroughs of 2017, and a quite surprising result. What happened, if you look at it a bit more carefully, that it took us 6 days to realize that there was this flaring blazar in the IceCube uncertainty region. And that's a long time, and we could have done more observations and more science in this week. And it wasn't really difficult to find it. All of the tools to do that were ready and available publicly at the time. So what do we need to do? If you get an IceCube alert, you do a search in the region defined by the IceCube contours, the localization uncertainty. There you see, you match that with a catalog of sources and you find TXS. Then you check the state of that source. Is that source doing something interesting currently? For example, we heard about the Fermi tools. Fava was available at the time. You just have to enter the coordinates of TXS again in Fava, see that it's doing a flare, and then you want to do a follow-up observation, and you need to check, is that source actually observable with my favorite observatory at this moment? And especially this last point was difficult at that time because many of us were at a meeting.
Yes.
I guess Phil was there and probably a few others. Eric, you in Amsterdam. There was a workshop during this week, and of course the Fermi circular came out half an hour before the official start of the conference dinner. So we didn't have our laptops. We tried to scramble it on our phones, and all these tools were not working on our phones. So we have to copy coordinates from degrees to hour, minute, seconds from one tool to the other, and it was a bit of a nightmare.
It was fun.
But a fun conference dinner. So, and the idea what I took away from that is that there are many tools at that time, and there are even more now. I mean, we heard this morning from Curtis all this long list of tools and logos. There are many more than 2017, but we need to interface them. We need to automatize connections between them, and we need to take advantage of modern computing interfaces like smartphones, because we don't have our laptops available all the time to run a Jupyter notebook. So then it took some while and to figure that out what we could actually do. So this is then 2 years later where we started to actually work on that. This is the first version of Astro-COLIBRI. So basically just a Python script with an interface doing exactly that. So you get an alert through GCN, pass that, get a region of the sky, do a cone search, and then find various sources in there. But it wasn't very user friendly, so we tried to put on top a more interesting interface. So there's this EEL framework. I'm not even sure if this still exists, which allows you to create an interface, a connection between a Python backend and some JavaScript HTML website. That was nice. It looked nicer than just the GUI-based interface, but it wasn't was only running locally on your machine, so you couldn't scale it and make it public. And then the first real version and the real change was implemented by Patrick during his PhD, where he basically tried to make this interface work and then decided to skip all that and start from scratch and put it in all the backend into an API, and then have this Flutter-based front end. At the time, it was very new, so Google just started to develop this multi-platform interface and programming language, Dart and Flutter. And these are already very similar to what we have right now. So we changed the interface quite a bit and added, of course, much more functionality to that. So that's what we have right now. I guess as you are here, you have all seen that. And I don't need to advertise that further. Just taking a step back now. So what we have right now and where we see Astro-COLIBRI in this huge landscape that we've discussed already today, and we're continuing discussing tomorrow with all these various tools and platforms and pipelines. Our main idea is that you have these detections. So you have these monitoring observatories. They send the alerts for all these variety of brokers. The most important one of them is GCN, but also TNS, various other analysis tools. For example, FlapLook is a tool, again, analyzing Fermi data as it comes in and sending alerts if there's one of the monitored sources going into an excited state. And of course, we have all the upcoming tools, LSST brokers, CTF at the moment, etc., etc. But the idea is to listen to all of them and have all the information at a single place, so you don't have to search for it at various places, but you get a nice overview. But then, of course, again, we don't want to reinvent the wheel, but we want to use and make available all the additional tools, platforms that have been built. So the idea is to interface with them, avoiding that you have to copy coordinates from one tool to the other. So if there's a tool that provides a kind of a deep link where you say, okay, these are my coordinates, or this is my source, and this is my time range, and I jump right into the crucial information, like I mentioned this FAVA tool, providing you a forced photometry analysis of the Fermi data. From Astro-COLIBRI, you just have a button where you see, okay, there's a TXS source, and you push the button and it opens the FAVA tool at the right coordinates and it calculates the light curve, and you see it doing a flare, so you don't have to do all this copy pasting back and forth between these tools. To have this single point of where you can start your journey across these platforms. And then, of course, you get all the information about all these detections. Of course, you have to filter them according to your needs. I'll come to that in a second. And then you can learn from the other platforms, is this particular trend and this particular event interesting for me? And then you can take the decision trigger follow-up observations. And while a lot of work has been going on over the last years, and I did a lot of things myself in the HES system to do all of these triggering of TOs and triggering of follow-up observation automatically. There's still a lot of things that we do manually, especially at the largest telescope, where people decide, I want to go after this or this event. And I think having a tool providing you all the information and helping you to do an informed decision is very helpful. But then again, you can try to facilitate this triggering. And we try to do that, for example, with the black hole TOM and the RAPAS networks. So these are two telescope networks where you can just, with a push of a button, start a deep and lengthy follow-up campaign, either within the amateur astronomy communities or more professional telescopes. So you see in your interface, we have all the information. You can also go a step further and request these follow-up observations. And there's certainly a lot of things to be done in this direction, interfacing with more tools. I guess we'll discuss with Curtis how we can interface with these TOM frameworks, where you can access to the actual telescope time you have available, so we don't need to reinvent this again. We just interface it, for example, with the TOM. Just one word on the current setup, so the architecture of all that. As I mentioned, we have this central API running on AWS, which feeds the front ends, and this is done through a real-time database called Firebase, which provides these streams of events. So if we add a new event in this database, it pops up right in the interfaces. You don't have to reload the interface all the time to see if there's something new. It's just streamed to you. New events are added by a separate service that's also running on AWS, where we have all these listeners listening to GCNs in their various formats, listening to the transit name server submissions, analyzing GCN circulars and all of these things. If there's something interesting that's being pushed then to the API, which then stores that automatically in this real-time database, and it fills a kind of a backup database that is more for long-term storage, and which we use for these cone searches, which until recently weren't very efficient on this real-time database Firebase. But then again, we don't want to build our system alone, so we have an increasing number of interfaces to external APIs, most of them provided by people in the room. Of course, starting with the usual suspects, or SIMBA, TSAR, GraceDB, downloading gravitational wave maps, stuff like that. We can also query ADS, searching for papers on interesting sources, searching for ATELs, for example. We query the Swift API to calculate a light curve of an X-ray afterglow for GRVs. Last year, at the workshop, people implemented a prototype of providing an optical light curve figure that has then been taken over by Dagmar and implemented. So we are querying the Assassin, the Atlas, and the CTF through the Think Broker photometry and create light curves for the recent optical transients. Recently, we are starting to use OpenAI to provide event summaries, more like for the general public, amateur astronomers, describing the events in a few easy to understand words. Also last year, during the workshop, we decided to implement a discussion forum to exchange with the user community have feature requests, discussions, announcements of our new releases and things like that. But also discussion about science or discussion of transients, where we can say, okay, this is really a very interesting transient. If you have telescope time, go observe. And then, of course, TilePy, that has been mentioned a couple of times, where we interface with the API to calculate these observation plans for gravitational waves for all kinds of telescopes. I should mention, of course, for the mobile interface, so on the smartphone, we have this messaging system that we use to send push notifications that people can customize, and then you get informed about new events coming in, and you can open the app and it loads the event at the right size. You should interrupt me. Do you have any questions so far on the technical stuff, on where we come from, what we're missing? No.
How many users do you have signed up? So that's not exactly a technical question, but I'm interested.
You can count users in a very many ways. So we have a few thousand installations of the smartphone apps. Mm-hmm. Both of them in iOS and Android, probably between 3,000 and 4,000 each. But that doesn't tell you about the usage. If you count individual users per month, this month is 700 or something. But then there are people coming back like me. I open it every day, so every day it's between 50 and 100. So it's often the same people coming back. Right? That's why the usage is difficult to quantify, but these are a few numbers, right?
Yeah,
The question.
Go ahead.
How much computing load can you push back towards Astro-COLIBRI? So, for example, if you have the data collected and someone then goes, okay, I'd like to fit this thing with this model, for example, would that be pushed back to and run on AWS, or that has to be client side?
No, I mean, for the moment, all the compute is done on our machines.
But is that limited? Like, if I want to have something that runs for a few minutes.
No, I mean, that's what we are discussing, I guess, tomorrow and on Wednesday, because I mean, for example, so I put it there, for example, this TilePy thing, we put it in a different AWS server because that takes a few seconds, few tenths of seconds, maybe a minute, depending on the complexity of your schedule. And we didn't want to interfere with the central API. So we just ramped up another machine, which is idling for 99% of its time. And then if there's a request, it can respond. So we have idle computing resources where we could implement other tools and calculations. Right? So we are not limited by that. And anyway, all of that AWS stuff is auto scaling. So if there would be hundreds of requests now per minute, we would just automatically ramp up a few machines in addition.
Yes, just about the latency of your answer from the start. After the detection by a satellite, how many time do you have for the data available in the Colibri system?
I don't have an exact number on that because it then depends on the event and what we do with that. So the bulk of the event just go through in a second or two.
My question is, are you hearing what comes from the server
Yes.
in among, or are you pulling every 4 years or every 4 hours?
Everything is pushed to the server. So as soon as something goes, it has been detected by Swift, they send it to GCN, they send it to us. So that's all pushed, then we react automatically on that.
You are not pulling every 6 hours? No, okay.
Except for the Transcend Name server, because they only announce their new detections and classifications by email. And we pass these emails every 5 minutes. So there you have a few minutes of cadence. Huh?
So is everything in your backend API, is that publicly accessible? Like, say I don't want to query the transient name server because it's an email interface or it's a CVS file I have to download.
Yeah.
Could a user access your API to query as well?
Exactly, yeah, totally. So let me use this as an excuse to. So the usual website that you probably know is astro-colibri.com. There's another one, astro-colibri.science, but you can also find it up there in this information box if you don't want to remember that. So that's .science, and that's where we have all our documentation and things like that. So you get all our proceedings and papers. You get the documentation, definitions that we use, resolutions that we have. The definition of all the notifications that I just mentioned, how you can filter the events, where the data comes from, the credits and all of that, and then the release history, where you find all the change logs of our releases. But there's also the API documentation. So the API is running on that server, right? So that's the .science server, and there's the API in the background, and you have multiple endpoints. The first ones which you use to calculate these visibility plots. Then is one for cone searches, or these latest trends where you can just the bulk of all transients fitting your filter criteria over a certain time range. So if you're interested in the last week or the last 2 weeks, as we do, I mean, these are exactly the endpoints used by our interfaces, right? So
is there any authentication behind it? Do you have to have like an API token to access any of these?
You get, if you have you can create an account in the Astro-COLIBRI platform just by your email address. And then you can, in your user settings, you get an API token that you can use to send to these, to the more compute intensive endpoints, which are the cone search and latest transients. The other ones don't have any restrictions, I guess.
You end up getting rate limited. Say you had a lot of users coming from Astro-COLIBRI and say you're querying the TNS, like will Astro-COLIBRI get cut off? Or well, I mean until.
I mean, we are not, these endpoints are not querying TNS because we already copied the TNS data to our database, right? And there, in these endpoints, there are rate limits. I guess it's 100 calls per day or something like that. But if you need more, you just tell me and I increase that. It's just to have some safety limit to not overdo it.
Yeah.
And then there are a few other endpoints also. You can query these light curves, for example, that people have implemented last year's hackathon. You get these Swift XRT light curves. You get just, if you know which event you're looking for, you can just get the information about these events. And there are a few of these Google Colab interactive notebooks to get you started. So there's a very general one which tells you how to find a given event by its name. You get the internal ID, and then you get the event information, and then these this cone search or latest transient endpoints also have a notebook there which tells you how to construct these filters that we use. So the filters are defined in a JSON structure. That's a peculiar, and then you can learn how to use that and how you submit your API token, for example. Things like that. It's all in these examples.
2 seconds, Fabian.
Yes.
Someone left a suitcase. Since we had to close the office, I prefer to put it here.
That's it.
The office is upstairs.
I don't know which one. Where did you leave your suitcase?
Just the welcome desk, because I was told to.
Okay,
I
so probably
did just do that.
the people from the welcome desk left, and therefore they put it outside. All right, yeah. So have a look at these endpoints, and if there's something missing that you would like to see, for example, I mean that's also the feedback we try to collect here. Right? So if you want to use the API with some other tools, just go for it. And then again, there's also the link to the discussion forum. That's running on the same thing, so forum.astro-colibri.science, to which you can subscribe again with the same account. So you just connect again, and then you can discuss either feature requests, or if you have issues in the help desk, or if there's some interesting transients that you wanna advertise. Let me put that to the side. So this is the interface that you get. If you're just a random user, so these, for example, these descriptions they're coming from OpenAI. So we have a few prompts sending our event information and trying it to summarize what's going on. You're probably not very interested in that, so you can switch to this science mode. So this text summary is replaced by the actual event information. I guess you have seen the visibility plots. So these are calculated automatically for each of the transients for the selected observatory. So you have this Google Maps symbol up there where you can define your favorite observatory that you use. You can also search for all of them in the IAU code, or you define your own, either using your GPS location on your phone if it's in your backyard, or you just enter the coordinates where you are. And another way of doing these visibility plots, and also to help schedule extensive campaigns, are these multi-observatory plots. So you can select among the list of all the observatories that I just showed you, and see which ones can actually observe. Just put random numbers in there, so you get an altitude coloring and a time when the given observatory would see that source and at which altitude, and if they can't access it for various constraints, then it's written. So if you want to have if you have access to multiple observatories or time at multiple observatories, you can decide which ones to trigger first, or which ones to use for this given campaign. We've been discussing the Einstein probe alerts. So this was just one that came through the Kafka stream. So we mentioned earlier on that apparently they don't send so many, but this is one of them. So that's another WXT detection that came through the Kafka, and the original notice is always given up there. So this is the information they've been sending up in this new GCN JSON format that our our friends from the Swarm Science Center probably can confirm that this is the case, right?
This one is the one from 9:30 this morning, right?
6:30.
Yes. There was another one before that. apparently.
Yes, this one. Yesterday afternoon. Gravitational waves are there. We extract the contours. So these are 50 and 90% contours. Nowadays they are so small that they're smaller than the marker size that we choose. But to get them, you get the thing which we started out to do. So these cone searches. There again, due to history, we started out to search for quasars related to neutrinos. So the catalogs that we use are the Fermi 4FGL catalog, then the TEFCAT that Derle is maintaining, and then a galactic catalog of SGRs, and the archival IceQ AstroTracks. That's certainly very restrictive and meant for high energy searches. So if you have other ideas, what you would like to see in these cone searches, let us know, and we can add more features there. Then of course, one thing to keep in mind is filtering. So you get more and more events. So you wanna pick the interesting ones for you. I guess you all know these buttons, so you can add the unclassified optical transients that have been submitted to TNS, and then you get the classified ones. And among the classified ones, we have another button for the supernovae. But if you long press on any of these buttons, you get additional filter criteria. For example, here the magnitudes of the unclassified ones. So if you loosen that up, of course, your diamond is full of stuff. For the classified ones, for example, we have the main classifications. So if you're interested in seeing only new novae being reported, then you remove everything else and only keep the novae, and then your sky map is much cleaner. Same for the supernovae, we just have the two types for the moment. Things we added recently also are these sub filters for the instruments. So for example, a GRB being detected by Swift is first reported in BAT and then followed up and to get a more precise position in XRT. So if you are only interested in the precise positions by XRT, so you remove all the only BAT reported GRBs.
Yes, when you make a long press, is it memorized in your profile? Yes.
All the subsettings are also stored in your user profile. So that's why you should create one of these accounts which help us synchronize the filter settings, for example, also between the web interface and your smartphone. So you don't have to re-enter your favorite observatory again or these filter settings and all that.
I would just add something on this. If we have an update with major, with some update on the filter, then your filter setting could be reset. So, but only when we make a new update and this update touch filters. If
Yes.
this update doesn't concern filters, you should not.
Experienced.
Yeah, that's you may lose your filter settings because we have to override them. That question?
I don't know if whether I missed it or not. Are the current ways of having priority alerts that sort of pop up that nobody can miss, like in the case of a galactic supernova that sort of take priority over everything?
No, but there's for example, so in the notification settings, so it's the mobile interface. So we have these special targets. So for example, if the Corona Borealis would go off, we have defined a special region in the sky around that. and if somebody reports a transient from that region, you get a notification if you are subscribed to these alerts. Galactic supernovae go there. They also go to neutrino alerts, and they go to supernovae. So if you're subscribed to any of these, you're not missed the next galactic supernova. We try to be as inclusive as possible. But there again, these are predefined streams. And there's certainly a way to personalize them and have more user-defined settings. Something we can discuss also during this week, what criteria you would want to define your own settings there, for example. The Swift light curve, I guess also, if you have a Swift detected GRB, you have you get Swift light curve figure that then queries our API, that queries the Swift API, and you get the latest light curve figure in comparison to archival data, so you can see if it's how it compares, because absolute values I can't deal with that. Same for gravitational waves. So you get the schedule button, which then calls the TalPy API and provides you this observation plan, which currently doesn't work because this is Hess, and Hess can't observe because of the moon. But play with that, and you see the list of events being expanded by list of proposed pointings in the sky, and then you can click on each pointing to get the visibility of that one and the table and things like that.
Yeah, so sometimes it could be depending on the parameters and stuff. It could be taken from a few seconds to a few minutes, or even in the worst case, 15 minutes to get the result. So don't be surprised if the result doesn't get away right now. But if you click again on the schedule button later, results are cached, so you will get it right away if you still have exactly the same observatory and everything for the same day.
How long is it cached for?
It's cached for the limitation is more you have the schedule for the next night. So as long as it's the same night, you will have the right away, and so the following day you will pass to the next night, and so there it's again.
I'm gonna show a brief example. It's not interactive. Screenshots on the mobile app.
Just the other thing, just a second, so before I forget it, so these are the new light curves. So for all the optical transients that you see in the default view there, we calculate these optical photometry light curves twice a day. So these are updated automatically twice a day using as I said, the data from CTF, Atlas, and Assassin, if available. You can also, so these are starting 5 days before the detection and going for a month afterwards. So that's why in this default window, which is 2 weeks, that's always up to date. If you want to have different settings, you can open this thing and select the start and stop date, and you get a more refined light curve if you need that. Again, this time window, of course you can select whatever you want. So or if you want to go back a few weeks, you can do so. You can also zoom in. That's maybe something not everybody knows. So you can select so if you select one of these bars in this light curve thing, you zoom in into 1 day or 2 days or things like that. So you don't have to fiddle with these date selectors.
Yeah, I had a quick question. I thought of it when you showed the notifications. So if I understand that correctly, is if you subscribe to all these things on your account, something happens within the field of view or whatever of your set observatory, right? Then you'll get a note on your cell phone say, hey, this thing happened, right? Have you guys, correct me if I'm wrong, are you guys, I know you're ingesting a lot of like Kafka subscriptions or whatever from like GCN and TNS, et cetera, et cetera. So you basically become a broker of brokers. Have you considered sending out like a unified, like publishing yourselves on a Kafka stream? So as I could say, rather than ingest, so as a telescope operator, rather than ingesting 20 different subscriptions, I could ingest from you guys. Is this something that
Something came up like that, but we never got around to do it. If there's a real use case for that, why not?
Okay.
I mean, so for the moment, we have these push notifications, but we don't push our events, right? So you can, something, for example, you can download the events. So in our internal messy format, so you have this download button, so you can, all the selected events you can download, and you get the JSON content that we have in our database, right? So and that you can ingest then in other tools, and we'll see a few of them tomorrow for the amateur astronomers, for example, they've been playing with that. So you can get access through these latest transient endpoints that we discussed earlier, or through these buttons in the front end. You can download all the events. If there's an interest, we could also set up a broker and push them somewhere. But yeah, I don't know.
I'd be happy to help.
Getting messy.
Super useful, but
yeah.
Yeah, moving forward, like, what's the process look like? Like, say I see something on Astro-COLIBRI, I'm like, oh, I can add to this. Is there a GitHub repository where I could make my own additions, create a pull request?
The code is not on GitHub. We discussed it last year and decided to go with this forum to exchange with people.
But there's no way for someone like me to actually contribute to the code?
Not yet. I mean, we can give you an access to because the code is on an Institute owned GitLab instance where external people can also request access. So if there's a real interest in contributing, that's easily doable. But the code itself is not public yet.
Is there a plan for it to go public?
If we have time to remove all our internal passwords and stuff. Then I mean, there's nothing blocking us from doing public other than that. It's annoying thing to do.
We thought about making the API public, the code, because that's in Python. This one here is in Flutter, Dart. I mean, that's not really known amongst physicists, so it wouldn't have much benefit to make that public, but the API is something that's more reasonable.
To clean it up a bit. Yeah, Jim, maybe just because the filtering stuff is important, and there's one additional filter that we implemented is this general filter, which has a bit more functionality. So for example, it filters based on the visibility of your selected observatory that is defined in the other pane that I showed you, and you can also modify that. Or for example, the follow-up network. So I mentioned the follow-up by Rapat, by Tom. Also the Unistellar Citizen Science Network, we're collaborating with them. So they are defining interesting targets for the Unistellar telescopes. You can, for example, keep or remove events that have been retracted. So for Fermi GBM retracts a GRB, so they get removed. You want to see only stuff that is visible during the night time, so you can filter going to the sun distance, and preparing the the arrival of more brokers and events being or the same event being submitted through multiple brokers for the LSST, possibly with different classifications, because each broker might classify the same underlying event differently. So you can select your favorite broker and see only these events and disregard all the others. Maybe just to finalize, so I just mentioned these submissions. So if you are a member of one of the two networks that we're currently working with, RAPAS and Blackboard Tom, you have this additional button there, and then you can just submit the current selected event to these networks for follow-up observations, which is kind of nice. Of course, you can do the same on your phone, so you see an interesting, I don't know, a nova going off, and you don't want to miss the first few hours of the rising light curve. You just submit it, and people start observing. And then, of course, you have this long list of the tools that I mentioned earlier on. So these are all the platforms that you know and you use, but then you can dive right into all of these. For example, I mentioned the FAVA, the Fermi light curve analysis. You get extinction values, you get the visibility plot on certain satellites, and the schedule of a few satellites for this position in the sky. So you can see, okay, this random position that I selected would be visible by Chandra and XMM, for example. And you see what they are doing, if you can override that or not. There are a ton of these links. For example, you can search for your favorite targets, if there are papers on that, on the new version of ADS, so this SciX platform. You get the cutouts from Penstars right away. So if you are observing in the optical and you want to get the reference images from Penstars, you get that right away. Just have a look. There's a link to the LSXPS to please fill to the empty thing. There are links to the different brokers, so Field, LSC, PSSIN, Post, photometry, like all of that. You also find links to the forum again. So there are these 3 links up top where you can share an event. So that just copies the direct link to an event in your clipboard, and you can share it with your colleagues, and they open it and it loads the interface with the event that you want to discuss. So this is the share event button. You can download them, what I discussed. You can jump into our discussion forum, and maybe also the download. So there you can download the links, but you can also download this filter structure that I mentioned earlier on. So if you have your filters defined in the interface, and then you want to use the same filters in an API call, you don't have to reinvent this whole thing again. You can download them in a JSON format, and you put that into the body of your API call. If you have an account, the filters, as we said, are stored in our user database. And if you send the user ID to the API call without any filters, it will load the user filters or your filters from your database. So you don't have to fiddle with that. But if you want to, you can play with that.
When you have a user ID, you can download your filters as user ID.
No, you just go there to click the button, I guess, because this filter setting should correspond to what is in your database anyway. And that's it. I think, if I didn't forget anything, but please feel free to ask or discuss with any of the team members over the next days.
Yeah, just another question. When you add the option add to RAPAS network,
Yeah.
Is it private? How do you let this appear?
You have to connect your user account to the RAPAS network. So if you're a
Okay.
member of RAPAS or Black Hole Tom, for example, so you go to the user account details, request observatory access.
Uh-huh.
Right? And then you get a list of observatories or collaborations that we work with who have private information to share or private functionality. So for RAPAS and Black Hole Tom, that's a functionality that you can submit events to there. So you click there, and we get a request that you want to join this functionality, that you want to get access to that. For Black Hole Tom, it's automatic because they have an API where you can request a token. So you just enter Black Hole Tom. There will be a talk tomorrow by Lukasz, so he will explain that more in detail. So that we call their API. You just log in with your credentials, and then we store your Black Hole Tom API key, which then allows you to submit the event to their API. So if you have other ideas, networks, telescopes, TOMs that we could use and facilitate the submission of follow-ups, just let us know. I mean, we're starting to do that, and I think that's quite interesting because it really facilitates the whole workflow from getting to know about a new event, getting notification, learning about the event, and then submitting it for additional observations.
Yeah, go back a few steps. So you were saying that you're listening to TNS and GCNs.
Yeah.
Do you actually parse the texts, or there's some machine readable data that it's being sent, and you take that from there?
The GCN notices are machine readable automatically.
TNS?
The TNS sends emails with the ID of the event, and then we query the TNS API to get the whole information. So we pass the email to get the ID. That's how they announce the event, and then we still pass GCN circulars to get the names, for example, for Einstein probe alerts or the GRB name. So if there's a GRB being announced via GCN notice, and then at some point there's a circular, we extract the name from the circular and update the information.
Okay.
Just one point on that. So update of information is a crucial thing because we always show the latest information that we have. So over the last minutes, hours, days, this might have changed. So you get, for example, the history of GCN notices there. So you can see the first notice that we got. So you get directly the original VO event information, and you get all of them. And you can also load directly the various versions that we had shown in our interfaces. So there's a history. Each time we modify one of our events, we store a copy of the old one. We can reload for this Fermi GBM GRB, the first one that we got. So you see that the position has moved from one version to the other, and then you just load the most recent one again. So you can go back in time to see why did I trigger follow-up observations on this position when now the latest information is showing it there, so you can understand what's going on, and you can go through this history.
For GCN circulars and TNS emails, how do you parse in the science mode? Because it may have different components as it is human written.
The three components, what do you mean?
So like in one email, like some are the standard information RA deck time, but there might have some different like extra information also in email. So how do you like parse and justify like?
So it's a very good question, and it's one of the topics that we wanna work on if you're interested during the hackathon. So for the moment, it's just regular expressions. So we search because we know that Swift has a template and Fermi has a template, and Einstein telescope is hopefully getting close to a template. So that's been oscillating a bit. So we know roughly what to expect. And then we pass these circulars for trigger IDs, for example, which we then use to identify the event, and the name of the event is typically in the title of the circular. Right? So you have just a bunch, and now there's quite complex set of regular expressions analyzing these circulars. But as you say, that there's much more richness in that. For example, also in ATELs that we don't pass at all because there's no fixed template for them. The idea is to use large language models to do so. So I have a PhD student who can't be here because he has to write up his thesis this week, who was working on putting in place a pipeline of natural language processing, analyzing ATELs and GCN circulars to extract source names, coordinates, times, what kind of source, what's going on, references between different parts of the text, different ATELs, for example. But all this started 3 years ago, and now over the last year or two, all these large language models have taken over. And I think we could have a small group of people looking into that, sending an ATEL to the OpenAI API and say, give me the source name, the coordinates, something like that. I mean, we tried that and it works surprisingly well. But we haven't put it into production yet. So lots of ideas, but certainly much more what you can think of, how to improve that, what to add, how to link additional services to all of that. And I'm really looking forward to hearing your ideas. But again, it's a sciathon over the second half of the week, so you don't have to work on Astro-COLIBRI and the API. You can also just brainstorm how to improve the whole multi-messenger time domain Astrophysics with different tools. So don't feel bound to that.
Yes, to ID, Fabian, it would be nice to have an overlay on your map with the location of the sun surrounded by a cone, 30 degrees, for instance, to show that it will be difficult in this area to have to follow a target, to monitor a target. And the second idea is maybe also to have an overlay with the ecliptic to show where the area where we may meet asteroids, which can be a false alarm source.
Yeah.
Two ideas like that.
Yeah. So for the sun thing, I mean, you can play with the sun distance filter, right? So
yeah.
We can see which events are currently blocked by the
yes, but
by the sun.
You may put the sun itself on the map. It will help maybe.
Yeah.
This is nice.
Careful not to overload the interface, but
no, it's an optional overlay.
Yeah.
So only that.
By the way, this map you can also move to galactic coordinates if you prefer, and to different projections, for example, if you prefer a map like that. I don't like that.
The sun that you just showed, the sun filter.
Yeah.
It's regardless of if the sun is below the horizon or not.
Yeah, it's the distance of the source to the sun.
Yeah, I mean,
at the time of detection
below
of
the horizon, it becomes irrelevant. Like if you are in Hertz, for example, you're at -18 degrees for the sun.
Yes.
If your source is at less than 45 degrees
That's why
away
you-
from
yeah.
the sun, it becomes irrelevant. Like that's what I'm
When you
saying.
combine it with the visibility of your
Yeah,
observatory.
that's my
Right, so,
Yeah,
so you cut everything which is outside your visibility range. And then you, in addition, you remove everything which is too close to the sun.
Okay.
But for example, the 45-degree in S, so you have a zenith limit of
I just,
60.
I just
And so you
gave
have
Hess
30
as an
degree plus
example.
18, so anything closer to 48 degrees of the sun, you will not be able
Okay,
to.
but if you use a cut of 60 degrees.
For space-based observatories, the angle for the sun is what matters.
Okay.
Because there is no, the sun's below the horizon, so you can observe it typically.
Just keep in mind that we don't update that number, so that's the sun distance at time of detection of the transient. So we fill that once in the database. If you look at that 2 weeks later, you might get spoiled. I think.